Hello and welcome. This is just going to be a rant about why pi is not the most elegant choice of the constant. It's really 2 pi that is the real constant. And, it's going to be a really unstructured, just sort of like rambling about this topic, because I think that there has been debate about it, but I actually think there's a solution to the debate. And I'm going to share that in this video. So first of all, pi r squared, area of a circle. If we were to write that in terms of tau, it would be tau over 2r squared. Clearly this looks better than this, right? What about the normal distribution? Well, we have 1 over sigma times the square root of 2 pi e to the negative x minus mu all squared divided by, and I'm going to put the parentheses around this. We're not going to go over the whole 6 divided by 2 times 1 plus 2 debate today. We're going to evade it by writing things clearly. Anyway, clearly this would look better if I replace that 2 pi with a tau. So if you just go through the formulas in mathematics, some of them look better with pi as the constant, some of them look better with tau as the constant. Of course, tau being equal to twice pi. So at that point, it's a bit of a stalemate, right? In fact, I think you could even argue that more formulas look better with pi, probably because it's smaller, and when you have to divide to make the formula work, it just sort of makes it even worse than having to multiply to make the formula work, right? But there's a solution to this debate, because I think that's the wrong way to go about it. We shouldn't be asking the question, which constant makes formulas look better on average? We should be asking the question, what is the best formula? And there is an answer to that. So, the most important function in mathematics, at least the most important function in mathematics that isn't super trivial and obvious, like the identity function. Okay, the identity function, maybe you could argue that's one of the most important, but really it's the complex exponentiation function e to the power z. And this is the way that pi or tau should be defined, is through this function. Many of you might be aware that e to the ix is equal to cosine x plus I sine x. And this function is so important and so special and so central and so beautiful that cosine and sine should be defined most beautifully, in my opinion, through the definition of this. And so on. So what does this say? Does this say that pi is better or tau is better? That's going to settle the debate. Now, this has some properties that are its most important properties. Some of that is just, sort of basic properties, like its asymptotic properties and things like e to the 0 equals 1 and all of that kind of stuff. Then you have slightly more profound would be e to the z, the derivative of it, is equal to itself, right? That's a really profound one. Very profound is e to the z plus w equals e to the z times e to the w. So this says that complex exponential function is a group isomorphism from the additive complex group to the multiplicative complex group. Very beautiful. It also explains why it's called the exponential function, essentially. What else? Well, you've also got other ones like that the magnitude of e to the ix is equal to 1. Very special. It's sort of like, what do you call it? Pythagorean's identity? Am I getting that right? Right? Cosine squared x plus sine squared x equals 1. That's what this, that comes from this, right? That's essentially a reframing of this. And then also, in my opinion, very beautiful and very important would be that the integral from 0 to, I don't know, let's say x naught of the magnitude of the derivative of e to the ix with respect to x. Sorry, I would have liked to use t there, but that this is equal to x naught. Very beautiful and important formula. Kind of describes what Euler's formula is really all about, in my opinion. So now let's get to the most important thing, is that the complex exponential function is actually periodic. It has a period. And what is that period? This is one of the most important formulas in all of mathematics, okay? E to the z plus 2 pi I is equal to e to the z, 2 pi I. So what I think we should do is we should say there exists a unique positive minimal real constant tau such that e to the z plus this special constant times I is just the same thing back again. Another thing you can say is that e to the tau times I is just equal to 1. So of course you might say, well, I think e to the I pi plus 1 equals 0 is more important. But is I pi the period of the complex exponential function? Not at all. You really only went halfway there. Here, you have the period. You've gone all the way around. And there is nothing for pi. I'm putting my neck out on this one. There is nothing for pi that is more central, more beautiful, more important than this right here. Anyway, that's it for me. That's why 2 pi, pi is a historical accident at this point. In retrospect, of course, it took a long time to get the retrospect to see that we chose the wrong constant, but now that we do have that retrospect, we have to give 2 pi the credit it deserves, in my opinion. Thank you for watching, and if you have any questions, feel free to ask. Take care.